a right-angled triangle, the lengths of the three sides are sine 2x, sine 3x, and sine 4x, where x is between 0 degrees and 90 degrees, and the hypotenuse is sine 4x. Find the lengths of the triangle. You may use the chapters below to jump to the section of thinking process and different parts of the detailed solutions.
Hi there! Welcome to my channel Mathusiasm. Today I want to share with you this question of sine ratio in right-angled triangle. Without further ado, let's get started. First of all, we're going to apply Pythagoras Theorem to set up an equation which is sine squared 2x plus sine squared 3x is equal to sine squared 4x. Here we're going to apply the double angle formula for sine 2x and sine 4x. While for the term sine 3x, we'll apply the triple angle formula. Next, we'll obtain an equation as far as the term sine x to the power of 6, which is a high degree polynomial equation. In order to simplify it, we let u equals to sine square x. Therefore, we simplified it into a cubic equation in u. To solve it, we'll have to factorize it using the factor theorem together with the long division, such that the cubic polynomial is factorized as a linear term times a quadratic term. For the quadratic equation, we can apply quadratic formula or using the method of completing the square to solve it. So that's all about the thinking process. Let's jump to the detailed solutions. In part 1, we're going to use the Pythagoras Theorem to set up an equation and to simplify it. As you can see in the figure, we're going to use 3 different colors for the 3 sides. So the equation is sine squared 2x plus sine squared 3x is equal to sine squared 4x. For the term sine 2x, we apply the double angle formula, which is 2 sine x times cosine x. And for sine 3x, we apply the triple angle formula, which is 3 sine x minus 4 sine cube x. Finally, for sine 4x, we have 2 sine 2x cosine 2x whole square. For the 2 terms on the left hand side, we'll take out the common factor sine square x. So we'll have 4 sine square x cosine square x for the first term. And for the second term, we'll have sine square x times 3 minus 4 sine square x whole square. For the right hand side, we'll apply the double angle formula for sine 2x and cosine 2x, which is 2 times bracket 2 sine x cosine x times 1 minus 2 sine square x, and then everything square. Actually, there are 3 different forms of the double angle formula for cosine 2x. As you will see very soon, we're going to obtain an equation in sine x only. So on both sides of the equation, we'll have the sine squared x term, which we can cancel out. And the reason is that because x is between 0 and 90 degrees, therefore sine x is positive. Next, on two sides of the equation, we'll have cosine square x, which will apply the identity 1 minus sine square x. So the first term is 4 times 1 minus sine square x. The second term is still 3 minus 4 sine square x whole square. And for the right hand side, we have 2 times 2, which is 4, an extra square, so it is equal to 16. And then cosine square x, we apply the identity to get 1 minus sine square x. And we also have an extra 1 minus 2 sine square x whole square. Now take a look at these terms, sine square x. So in order to simplify the equation, we will let u equals to sine square x to lower the degree of the equation. Now the equation is 4 times 1 minus u plus 3 minus 4u whole square is equal to 16 times 1 minus u times 1 minus 2u whole square. Obviously, we'll expand both sides to simplify it. Left hand side, we have 4 minus 4u plus 9 minus 24u plus 16u square. And the right hand side is 16 minus 16u times 1 minus 4u plus 4u square. On the left hand side, I'm going to use double underline for the square term and single underline for the linear term. So the left hand side is 16u square minus 28u plus 13. And for the right hand side, we expand in such a way. First of all, 16 and minus 16u times 1 to get the same terms. Next, 16 times minus 4u and negative 16u times minus 4u, and we're going to write in a very special way, which is negative 64u plus 64u squared. The like terms are written along the same vertical column, so we can do addition and subtraction easily. Finally, 16 times 4u squared and negative 16u times 4u squared to get 64u squared minus 64u cubed. Finally, putting negative 64u cubed to the left hand side, and then 16u squared minus 128u squared, which is negative 112u squared. Negative 28u plus 80u is equal to 52u. And finally, 13 minus 16 is negative 3 equals to 0. We end up with this cubic equation in U, and we're going to factorize it in part 2. In part 2, we're going to solve this cubic equation by factorization. First of all, let the left-hand side of the equation as a function f of u like this. To get some linear factors of the function, we look at the constant term negative 3 and also the leading coefficient 64. For the constant negative 3, the factors are plus or minus 1 or plus or minus 3. And for the leading coefficient 64, the factors are 1, 2, 4, 8, 16, 32, and 64. For these values, they can be regarded as denominators. Therefore, if we take 2 as the denominator, using the red values as numerators, then we may try plus or minus 1/2, plus or minus 3/2. Similarly, if we take 4 as the denominator, then we may also try plus or minus 1/4, plus or minus 3/4, etc., etc. So we'll try u equals to these values to see which one gives the function values equals to 0. After several trials, we get the following. if we put u equals to 3 over 4 into the function, like this, then the function value is equal to 27 minus 63 plus 39 minus 3 is equal to 0. Then we obtain a very important conclusion. Based on 3 over 4, we get 4u minus 3 is a factor of the function f of u. For this whole process, it is called the factor theorem. Next, we're going to divide this cubic polynomial by this linear factor to obtain a quadratic one. Just like division of numbers, we copy this cubic polynomial as the dividend and the linear factor as the divisor, like this. Next, let's look at the first terms, 64u cubed and 4u. So 4u multiply 16u squared is equal to 64u cubed. We write 16u squared here so that the u squared term are along the same vertical column. So of course the first term must be 64u cubed. Next, negative 3 times 16u squared is equal to negative 48u squared. Next, we'll have to subtract these two expressions. This part is a little bit different from that for numbers. For the first term, obviously they cancel out, while for the second one, let's write down the extra negative sign here. Then it's actually negative 112 minus negative 48. So it's actually negative 112 plus 48, which is negative 64u squared. Next, we bring the term 52u downwards, like this, and then continue the division. So for negative 64u squared, we should have 4u multiply negative 16u to get negative 64u squared. Next, negative 3 times negative 16u is positive 48u. Again, after subtraction, the first two terms cancel out, while for 52 minus 48, it is 4u. Again, we bring negative 3 down. So finally, 4u minus 3 divided by 4u minus 3 is obviously 1. So the division is completed. This process is called the long division. In other words, the function is factorized into 4u minus 3 multiply this quadratic expression like the following. We'll have a product of two terms. The first term is the divisor, 4u minus 3, and for the second term, it is the quotient, 16u squared minus 16u plus 1. Now we're ready to find the values of u and x in the final part to solve the whole problem. In the final part, we're going to solve for the angle x and reject some impossible values. Previously, we factorized the cubic polynomial, therefore u is equal to 3 over 4 or 16u squared minus 16u plus 1 is equal to 0. In part 1, we have u is equal to sine square x, so for the first one, we'll have sine square x is equal to 3 over 4. Taking square root on both sides, therefore sine x is positive root 3 over 2 or negative root 3 over 2. However, the given condition is that x is an acute angle. Therefore, sine must be positive, and that means the negative value should be rejected. For the positive value of sine, x is equal to 60 degrees. However, this value is also rejected. The reason is that because sine 4x, the length of the hypotenuse, is equal to sine 240 degrees. And this is negative root 3 over 2, which is smaller than 0. So it's impossible for a length to be negative. Therefore, this value is also rejected. Now let's focus on the quadratic equation, and we'll solve it using the method of completing the square. First of all, we keep the first two terms, 16u squared minus 16u on the left, and then putting the term 1 to the right hand side as negative 1. On both sides of the equation, we're going to add a constant so that the left hand side is a perfect square. We're going to add 4 on both sides. Therefore, the left hand side is actually 4u minus 2 whole square. You can check this by expanding this perfect square as a squared minus 2ab plus b squared. While the right hand side is 3. So taking square root on both sides, 4u minus 2 is equal to plus or minus square root 3. So u is equal to 2 plus or minus square root 3 over 4. Now sine square x is 2 plus or minus root 3 over 4. So taking square root, sine x is equal to positive square root of 2 plus or minus root 3 over 2, or the negative square root. Again, just like the case of sine x is equal to minus root 3 over 2, therefore it is rejected. While for the positive value, we'll have a square root inside a square root. We call this a compound surd. And to simplify this compound surd, we'll do the following. For the positive value, we'll simplify it in this way. So sine x is equal to 1 over 2, and then inside the large square root, we will have 2 plus or minus square root 3, and then multiply 2, divide another 2 in the denominator. The reason is that because we like to make use of the identity a squared plus or minus 2ab plus b squared. If we take a is square root 3 and b is equal to 1, then we need 2 square root 3. That's why we have extra factor of 2 here. Let's continue. We'll have 1 over 2 and take out this square root 2 outside. Inside the large square root, we'll have 4 plus or minus 2 root 3. So we'll have the term plus or minus 2ab, and we hope that this 4 can be written as a squared plus b squared. Next, it is equal to 1 over 2 root 2. So for the middle term, it is plus or minus 2 times square root 3 times 1. And fortunately, a squared, root 3 squared, and b squared, 1 squared, the sum is really equal to 4. Therefore, we obtain this form, which is a perfect square, a plus or minus b whole square. So sine x is 1 over 2 root 2. Inside the large square root, we have square root 3 plus or minus 1 whole square. And obviously, this square and square root cancel out. So we have root 3 plus or minus 1 over 2 root 2. Let's rationalize the value by multiplying root 2 over root 2. Then we'll come across a very special form. Sine x is equal to root 6 plus or minus square root 2 over 2 times 2, which is 4. For the difference, root 6 minus root 2 over 4, x is equal to 15 degrees. While for the sum, root 6 plus root 2 over 4, x is equal to 75 degrees. Again, the value 75 degrees is too large because sine 4x, the hypotenuse, is equal to sine 300 degrees, which is minus root 3 over 2. Again, this is negative. So 75 degrees is rejected. Finally, putting x equals to 15 degrees to find the length of the three sides of a triangle, which are sine 2x, sine 3x, and sine 4x, then we get sine 30 degrees, sine 45 degrees, and sine 60 degrees. We have these special angles, and the values are 1 over 2, root 2 over 2, and root 3 over 2. Finally, let's double check these values to see whether they satisfy the Pythagoras theorem. For the two shorter sides, 1 over 2 whole square plus root 2 over 2 whole square, it is equal to 1 plus 2 over 4, which is 3 over 4. While for the hypotenuse whole square, this is also equal to 3 over 4. Therefore, these three values are correct, and that means x is equal to 15 degrees only. I hope you enjoyed this video. Please give me a like, share, and subscribe my channel. I'm happy to see your views in the comment section below. That's all I have for you today. I'll see you next time. Bye.